Good morning, students. Welcome to physics class. As we have introduced the concept of electric field and electric potential. Now today we will establish a relationship between electric field and electric potential. This is important from derivation point of view as well as applicative point of view. Many conceptuals and numericals can be solved with the help of it. Let me start. Topic is relation between electric field and electric potential. Let Q be the positive charge situated at point O. Now, let we have 2 points A and B within its field. Let E is the electric field due to this positive charge which is directed outward. Let these 2 points A and B are separated by distance dr. As we have taken these 2 points separate, but we assume here that the 2 points are so close to each other that electric field will remain constant at these 2 points. We have to choose points in such a manner. Now, let me assume that at point A, potential is V. And at point B, potential is V plus dV. So now, when we have to move a charge from point A to B, it means then force will be required to move any charge. So let me assume that any test charge Q0 is present at point A. To move this charge from point A to B, we have to do some work. That will be against electrostatic force of repulsion. So now, first of all, force required to move test charge. Which one? Q0 from A to B, from one point to another. This force will be given by Q0 into E. Now, as work done to move charge Q0 from point A to B, this work done will be taken as F dot dr, force into displacement. Substitute the value of force from this equation. Q0 E dot dr. Expand this dot product. Q0 E dr cos theta. Now see in the figure, as field is acting outward and displacement is inward, that means towards the charge. So angle between field and displacement vector will be 180 degree. Angle is 180 degree in between electric field and displacement. Why? Because electric field is towards right and displacement is from A to B, that is towards left. So here we will take theta to be 180 degree. Therefore, work done will be Q naught E dr minus 1. That is minus Q naught E dr. This is the work done. See, we have taken this angle 180 degree corresponding when the point is here from A to B. Maybe point A can be here somewhere in the field. It means with the field angle can be different. So at many a place we will take this result as directly E dot dr. So don't get confused. We are taking here only one specific case when electric field and displacement are in opposite direction. But if the angle is other than 180 degree or some other general angle is there, so we will not take angle particularly, we will use it as E dot dr. You have to just learn this point. Now, as by the definition of potential difference, work done is given by Q0 into VB minus VA. You can write it as this is a change in potential corresponding to point A and B, and at point A potential is V and at B it is V plus dV. So the difference will be V plus dV minus V. That will be, this is Q0 into dV. So now from equation 1 and 2. Now Q naught dV will be equal to minus Q naught E dr. So Q naught will cancel out. E will be equal to minus dV upon dr. This is a result which you have to learn. This derivation is important. Then first step, you have taken we have taken charge Q at point A, O, and electric field is acting towards right. Considering 2 points A and B, having potential V and V plus dV. Then force required to move the test charge from A to B. Then work done to move the test charge from A to B. Then again applying another definition of potential difference and work done. That is, work done is Q naught VB minus VA. This is important. You have to learn these two results. F dot dr is the first one from where we have calculated this one, and second, this is the relation with the potential. So Q naught VB minus VA. Now from first and second, electric field comes out to be minus dV upon dr. Now this is the mathematical part. Now what is the significance of negative sign? So negative sign, what does it mean? It indicates that electric field increases in the direction of decreasing potential. Where potential will be more, where potential will be decreasing, electric field will be increasing. So you can take it as that negative sign indicate electric field is always in a direction of decreasing potential and vice versa. Right? Now, this is a general expression we have taken. If we have to express it in terms of coordinates x, y, z, then Ex can be minus dV upon dx, or del, in terms of del we have expressed, then minus dV upon dy, and Ez will be minus dV upon dz. It will be used when you have given electric field in terms of only one coordinate. Or in general form, this is the specific result you have to learn. Now, from this result, if we have to express V in terms of electric field, so you can write it as E is equal to minus dV upon dr. So you can write it as dV equal to minus E into dr. Here I am taking that somewhere if it has been given this is minus E dot dr. Don't get confused. Many a time this has been taken or this has been taken. You can take it directly. So now from the step dV equal to E dot dr. Now what we will do in next step, here we will take integration as we have to find potential. So let potential at two different points when the charge has been shifted from one point R1 to R2. Position with respect to origin obviously we are taking. So this step we are doing to calculate the value of V in terms of electric field. So here integrated you will get V2 minus V1 because you will get 1, this is 1. Integration of 1 is V, and substituting the value you will get this result. So I am taking it directly. Now this is minus E dot dr R1 R2. If we take charge Q naught, test charge has to move from infinity to a point. So at infinity potential V1 will be 0. Why? Because we know potential is inversely proportional to R. More will be the distance, less will be the potential. And let R2 position is at having position R. So potential, let we take it as V. So now substituting the value, V will be equal to minus, this is infinity to R limits, E dot dr. So this is another formula that sometimes can be used in numericals. It can be without limit, that is we have specified only, that is starting point to end point. So you have to learn this result also. This will be used in numericals. Now, after introducing the concept relation between electric field and potential, now next very important topic we are taking, equipotential surfaces. As first of all, let we generalize this equipotential. Equi means equal, potential that is same potential. The surface is having same potential at every point. So equipotential surface, it is a surface at every point of which potential is constant or same. This is the main point, potential remaining to be constant at every point of the surface. Suppose any surface we are taking, at every point of which if potential is same, that is taken as equipotential surface. Now, as we know that potential is given by kq upon r. So, for fixed distance, potential will be same as v is inversely proportional to r. V will be remaining constant. Now, let me discuss few properties of equipotential surface. As first of all, we will take the basic definition of potential difference as VA minus VB. This is work done in moving a charge from B to A. So now, if the surface is equipotential, if the 2 points A and B are lying on a surface, then potential at A and B, suppose we have this surface and we have to move a point from A to B. So, or from B to A. As these are lying on the same surface, so potential will be same. Now, from this result, what will be the work done? This will be VA minus VB, that is V minus V. This will be 0. This implies work done will be 0. So what we conclude? Very important point. This will be used in conceptuals. No work is done in moving test charge. No work is done in moving test charge from one point to other point on equipotential surface. This is the conclusion. No work is done in moving a test charge from one point to another on equipotential surface. Sometimes its proof can be asked in short. Now, after this we are taking second property. What is it? That electric field is always perpendicular to equipotential surface. As we know that potential is given by minus E dot dr and potential is given by work done per unit test charge. As by the first property, as no work is done in moving a charge from one point to another on equipotential surface. So work done 0. What does it mean? This factor will be 0. It means E dot dr, this will be 0. It means E dot dr will be 0. So E dr cos 90. Now here, what does it mean? This will be resulting 0. E cannot be 0. Dr cannot be 0. It means cos function, cos theta will be 0. And it is possible only when angle between field and displacement is 90 degree or pi by 2. What does it mean? That electric field and displacement are perpendicular to each other. So this is a proof and we can use this result directly also. So electric field is perpendicular to equipotential surfaces. Now, third property. As we have taken that electric field is given by minus dV by dr. So basically what we conclude that equipotential surfaces indicate the region of strong or weak field. What is the meaning? Strong or weak field. We can say that dr is also be written as minus dV upon E. It means dr is inversely proportional to electric field. What does it mean? That equipotential surfaces are far apart. Far apart means distance increases in a region of weak electric field. Means if in a region electric field is decreasing, then separation will increase. Inversely proportional, this factor will be less, this will be more. And vice versa, if electric field will increase, separation distance will decrease. So that's why we can say that equipotential surfaces are far apart in a region of weak electric field and vice versa. So this is the third property of equipotential surfaces. Now, next one particular property, that two equipotential surfaces cannot intersect each other. What does it mean? Suppose this is one equipotential surface having potential 10 volt, another equipotential surface having potential 15 volt. So at this point of intersection, see, there is no concept of direction. So how to understand? For this surface, this point must have potential should be 10 volt. For this surface corresponding to this point, the potential should be 15 volt. So this is a contradictory statement. At a single point, potential cannot be different. So that's why at the point of intersection, there will be two values of potential. That can never be possible. So if they will intersect, there are two values, which is not possible. So in short, we have taken four particular property results as no work is done in moving a test charge from one point to another on equipotential surface. Second, electric field is perpendicular to equipotential surface. Third, equipotential surfaces having corresponding result that where the reason where electric field is more, separation between the surfaces will be less. And the fourth one is two equipotential surfaces can never intersect each other. Now we will study to draw equipotential surfaces. How to draw it for different cases. So we will take them one by one. How to draw? First of all, we are taking for a point charge. Point charge. That point charge can be positive or negative. First of all, as we know, potential is equal to kq upon r. When r is fixed, constant, potential will also be constant. So if we say, we have taken positive charge, you can similarly take negative charge also. You can draw it for negative charge. So if we are taking this particular distance, let it be r1. So if we draw equipotential surface surrounding it at fixed distance, as it is at fixed distance, radius is fixed, potential will be constant. And if we are taking another distance, like this, as we are taking for different positions, potential surfaces are drawn by concentric circular arcs. So here we have drawn around this positive charge equipotential surface. If you will draw for negative charge, the surface will be identical. One point that you can say that now for this surface I am using property also that electric field will be perpendicular to this surface. If you will take negative charge, the sign will be, the field will be directed towards the charge. So you have to draw, this is homework, then draw for negative charge. Draw equipotential surface for negative charge. Second, we are taking for an electric dipole. See, electric dipole consists of two equal and opposite charges. Two charges of same magnitude, opposite polarity, separated by a certain distance. Now, if we have to draw equipotential surface for each of the charge, it will be of spherical in shape around it. Now, what will be the effect, influence of each other? So, what will be the effect? That in between the charges, their surfaces become closer. How? Like where we are drawing equipotential surface around it for positive charge, due to attraction, the surfaces somehow representing closer, and I have drawn this for positive charge. Now let me draw for negative charge also. This is one. Now due to attraction on this side, the potential surfaces are narrower. Sometimes it has been asked, such kind of questions can be asked in the exams. Now you can see here, this is normal border, but here due to force of attraction, these are lying just closer to each other. The surfaces are closer in a region in between the two charges. While drawing, you have to just be careful about it. I hope it is clear and you have drawn it. Now, third point, that we are taking for two equal positive charge. I am drawing it for positive charges. You can draw it for two equal negative charges. Similarly, you will take two charges plus Q and plus Q. Again, draw equipotential surface around it. Now, as we are drawing, as two like charges repel each other, so due to repulsion, there will be the shape that this repulsion is represented by. Let me completely draw it. So when we are taking two positive charges, you are observing that there is a force of repulsion. So due to repulsion, the surfaces are far apart in between the two charges. Here these were lying closer in between, but here the surfaces are lying far apart from each other in between the charges. So while drawing these 2 points, you have to draw it very carefully, especially you have to focus on the points where the surfaces are lying closer and at which point the surfaces are lying far apart. Now similarly, you have to draw for the two equal negative charges, you have to draw equipotential surfaces. Now, next we have to draw equipotential surface for uniform electric field. So, if the field is uniform like this, uniform electric field is represented by equidistant parallel lines. Now, so for uniform electric field, if we have to draw equipotential surfaces, these will be equidistant parallel planes. Like this is the plane we are taking. Equidistant parallel planes you will take. Equidistant. This will be represented by equidistant parallel planes perpendicular to lines electric field. Now, equipotential surface concept is quite very important here, especially there is NCRT exercise. There are certain questions that can be asked on drawing or identifying equipotential surfaces. So you have to just practice it by drawing. Otherwise, it is quite easy, and a slight mistake you can lose your marks here. And so today let me recapitulate in brief what we have done today. So today we have done one relationship between electric field and potential. So that relation was E equal to minus dV by dr, and from that we have also obtained V is equal to minus integration of E dot dr. Then next we have introduced the concept of equipotential surfaces as a surface having potential constant at every point. Then we have studied its different property, as no work is done in moving a charge from one point to another on equipotential surface. Second, electric field is always perpendicular to equipotential surface, and electric field is inversely proportional to separation. More will be the electric field, less will be the separation distance, and two equipotential surfaces can never intersect each other. Apart from it, we have drawn equipotential surfaces for different cases. Now whatever work I have given, just do it by practice. It will help you to learn the things in a better way. So I hope you understood all the concepts, and if you have doubt you can ask me. Thank you. Have a nice day.